Welcome to lesson 2.4, where we will learn why calculus is helpful to physics. So if you're wanting me to explain in depth how that works, that the first derivative is the same thing as the velocity and the second derivative is the same thing as the acceleration, you should go watch the freestyle, because I'm going to go through that, all of it, all the way through. And by the way, that is where I'm making sure that I introduce to you the idea that you're going to get points just for stating that you know that calculus is useful to physics. But I'm going to keep going over that as we move through these problems. So for example, if s of t is equal to t cubed plus t, and I want to find the velocity, I'm going to make sure that I state, that the velocity is equal to the derivative of the position function. And so the derivative of t cubed is 3t squared, and the derivative of t is 1. And so now I have my velocity function. And then if I want to find the acceleration, I will go ahead and state that the acceleration is going to be found by taking the second derivative. And here we have the derivative of 3t squared is a 6t, and then plus a 1. Now, I try to do my t's either like this or like this, so hopefully you guys will feel good about it. My s functions are terrible. I have terrible s's. That's the difference between an s and a 5. There's really not much difference here. So I apologize if you're having trouble. Just listen while you watch the video, and hopefully that'll help. All right, so when I'm looking at examples 2 through 11, I'm supposed to use this function right here. And so I'll answer each question as it's come up to me. When I need to find a derivative, and if I've already found it somewhere else, I might just use it later on. So what is the initial position of the function, initial position of the object? Remember that we have these notes where we say that s of 0 is just the number that's hanging out at the end. But again, I wouldn't mind taking just one more time to sort of prove that the position function initially will be located when t equals 0. So I have 16 times 0 being cubed, and I have negative 36 times a 0 being squared, and then a 24. And I know that that's 0, and I know that that's 0, but I still have that 24. So s of 0 is 24, and s sub 0 is also equal to 24. So if you recall from our freestyle notes, we will write a position function, in that sort of notation where I say, oh, hey, my position function contains some sort of function in it, but at the end, whatever is being added or subtracted, we go ahead and call that f sub 0. So this is a notation that I'm reminding you that from the freestyle, to make sure that you don't forget that s sub 0 is just the number that's hanging out at the end. But you can always find it by plugging in 0 as well. So then what is the velocity of the object at t equals 1 second? The velocity is going to be the same thing as the position function's derivative. So I'll state that, v of t equals s prime of t, and that thing equals the derivative of 16t cubed is 16 times 3t squared, and minus 36 times 2t, and the derivative of 24 is a 0. So then don't forget that initial position does not affect your velocity. That initial position is just where you happen to be located once you get started. All right, and you can actually leave it like that. If you wanted to simplify it because you need to find out what it is at 1, then I would say 16 times 3, v of t is 16 times 3 is 48t squared, and that 36 times 2 is 72. Let's make that a negative 72. And then if I want to plug in 1, I can find out that 48 times 1 being squared minus 72 times 1 is going to end up being v of 1 ends up being 48 minus 72. I leave you to find that. All right, so what is the speed of the object? Oh, I suppose I'll find it. All right, then it's negative 24. So the velocity is allowed to be negative. We already discussed the concept of why, so don't let that bother you. We plan to take the absolute value of the velocity function in order to find that speed, and therefore the absolute value of negative 24 is a positive 24. Now, don't forget this last piece. As we discussed in class, distance units are measured in feet and time units are measured in seconds. So I always want to make sure that I go in there and say for position that I'm just talking about feet, and that for velocity I'm going to be talking about feet per second, and for speed I'm going to be talking about feet per second. So what is my acceleration of the object then at t equals 1 second? Remember, I'm going to use this derivative up here because I remember that the derivative of the velocity will give me the acceleration. So this is a good moment to remind you that you should state that. For the AP exam, there are points awarded for you just saying that you know that when you take the derivative of velocity, you get the acceleration. And then if I'm going to take the derivative of that up there, 48t squared, I got 48 times 2 is 96, and the t goes down to a power of 1, and then the derivative of negative 72t is just a negative 72. If I want to evaluate this at 1 second, I'm going to pre-draw in my ones. Here we go. A of 1 equals 96 times 1 minus a 72. I'm substituting in ones for t's, and what I'll end up with is that the acceleration at 1 second is going to be 24. And by the way, this one's kind of easy for me to forget, so I want to mention that when you do velocity right here, we did, what did we do? We said velocity. I could spell velocity. Velocity is distance over time, which is how we got feet per second, right? And then here for number 5, if I want to do acceleration, I should remind myself, and I hope you will remember this, the acceleration is the same thing as velocity. I'm running out of space here. Over time. So that's how I end up getting the units that look like this. Ready? I'm going to do feet per second, and I'm going to put that over time. Again, gives me more seconds. So that's why we write, ready, feet per second squared. All right? And please be careful of that, because everything in orange, that's worth a point for you on the AP exam. Using the correct units is important. For number 6, it says, when is the object at rest? So it turns out that if I have a velocity, meaning if I am moving, then it's not at rest. So meaning if the velocity is 0, right, and I don't have any velocity, I'm not moving anywhere, that's when I'm going to be able to find out when the object is at rest. So I'm going to say, let's look for when v of t equals 0, and I'll say that v of t was 48t squared minus 72t. That equals 0. And looking at it, I know it's not obvious, but you can actually factor this. A 24 goes into 48 and 72. And so I end up with a 2t minus a 3, because 3 times 24 is 72. All right, and that equals 0, and I can factor this and solve. And by the way, 24t equals 0. Well, then t must equal 0. And 2t minus 3 equals 0. Well, then I'm going to end up with t equals 3/2. And again, both of these are going to be in seconds. All right. Now, if I now know when the object is at rest, that's phenomenal. I'm very excited about that. And I'm going to draw here what we're eventually going to be using a lot of. Remember this velocity number line, where I can mark that I know what's happening at 0 seconds and I know what's happening at 3/2 seconds. And what I know that's happening is that the velocity is 0 there. So I want to know what's happening in between those movements. Again, we discussed if you have an object that's moving right, you should have a positive velocity. And if you have an object that's moving left, you should have a negative velocity. And how do I test this? I go through it with a little table, which is optional. Okay, you don't have to go through this table the way I do. I'm going to come back to this number line, and this V number line is acceptable on the AP exam as long as you label it. That's the number line that I'm working with, is the velocity. And so over here, I like to make a little table, and I say, hey, I know what T is, and I'm going to check to see what V of T is. If T is 0, then V of T was 0. If T is 3/2, then V of T is 0. And that table makes a little more sense to me than the number line. So it turns out you don't have to use the number line on the AP exam. If you don't want to, you can always make this sort of a table. Now this section right here, where we're talking about when time is negative, leave it off, because obviously there's no negative time in this kind of problem. Later on, when we're doing the first candidate test, where we're looking for critical numbers, you will be able to look at negative numbers because it'll be pure math. But right now we're applied, so we don't have to worry about negative time. Inside of these intervals between this 0 and this 3/2, I'm going to put a box around both of these. I want to know what's happening right here. You know, and so what second would that be? What's a second that's between 0 seconds and 3/2 seconds? It turns out it's, when I said a second, hey, 1 second. What is happening? Is my velocity going to be positive? Is it going to be negative? I don't know. I can do this mentally, but right now I'm going to show you that I say that 48 T is squared minus 72 times a T. I know that 48 times 1 is just 48, and 72 times 1 is 72, but it's negative. So what I end up here is 48 minus 72. And you know what? I don't even care if that number, you know, what particular number that is. All I know is that 48 is smaller and 72 is bigger. And so if I take a small number and I subtract a big number, I'm going to end up with, ready, a negative number. Now, hopefully it doesn't bother you that I'm not actually going to find that number. I just don't care. What I care about is that my velocity function is negative there. So that's when I'm moving left. And I would like to assume that I'm moving left from here and here. But here's the thing. Just because I hit a velocity of 0 at 3/2 seconds does not necessarily mean that I'm not just going to pick up and keep moving in the same direction again. Imagine that you're on the freeway. We've talked about this. If you're on the freeway and if there's a traffic jam, you will come to a stop. But that doesn't mean as soon as you start moving again, you're going to go backwards. You're on the freeway. You could continue to go forwards. And so we don't actually know what's happening outside of this interval. I know what's happening inside of that interval. I'm definitely moving left, so I know the answer to number 8. But is there a time when I am moving right? Well, sure, I could check at a time that's greater than 1.5 seconds, right? 3/2 is 1.5 seconds. And so what number would you like to check at? I don't know. I like 10 because 10 is like a nice round number and I know how to square that. So I'm going to keep working on this. I'm going to say 48 times 10 being squared minus 72 times 10. Look, 10 squared is 100 and 48 times 100 is 4,800 minus 720. Again, I don't even care what the answer to that is. I guarantee you that number is positive because 4,800 is bigger than 720. And so I can come in here and I say, no, in this case, I am not on the freeway. My object starts to move right at 3/2 seconds. So right now I'm going to write that down. I'm going to say the object is moving right when T is greater than 3/2 seconds. Now, if this was one of those moments where I was going to talk about negative time, I would test in this region as well. And by the way, I would get a positive. So I could say that when T is less than 0 seconds, I know that we are definitely also moving right. And I'm not doing that because of this real world problem, but it is possible to state that. All right, so you'll see me do it when we start doing, you know, real, really theoretical problems. All right, so when is my object moving left? My object is moving left when I am between 0 and 3/2 seconds. Now, there is one other thing I'd like you to do here, is that go ahead and, again, for the graders, state that if v of t is positive, is when I find out that I'm moving right. And right here, go ahead and state for your graders that when v of t is negative, that's when we know we're moving left, okay? And if you want to use inequalities, you could do it like this. V of t is greater than 0, or v of t is less than 0, all right? But actually, writing words is totally acceptable as well. So then for number 9, it says, when is the velocity of the object equal to 54 feet per second? And we want to take a look at this function. Basically, it might not be possible to factor this by hand. Even if I could, I don't really feel like it right now. Why don't we break out a calculator? So my velocity function was 48t squared minus 72t, and I want to know when the velocity is equal to 54. And the secret to these kinds of problems is literally when you say that sentence out loud. When is the velocity, ready, that the velocity is 48t squared minus 72t, when is that equal to 54? Ta-da, it turns out my calculator has this beautiful function called solve, and it can give me my answers. It can give me real answers. I mean, it can give me answers exact, or it can give them to me in decimals. I love those decimals. I totally want to write those down. Okay, so negative 0.549 and 2.049 are going to be the two answers that I can write down. And I love using my Inspire with a CAS. That's definitely a CAS function. I know that. So what do you write down? You should write down 48t squared minus 72t and see when that equals 54. How do I do that? I'm going to say that t equals negative 0.549, and remember your seconds here, and t also equals 2.049 seconds. And again, this answer is extraneous. You don't have to write it, okay? Just like we could check to see what's happening at negative time for the problem above. If we get an answer that doesn't make sense in the context of a real world problem, then we just leave it off. There's no such thing as negative time here. All right, so what is the displacement of the object between t equals 0 and t equals 2 seconds? And displacement, we haven't had a chance to talk about yet. So let's discuss right now, what does it mean to be displaced? It means to be moved from one place to another. So displacement has a formula, and I want to make sure that you know that you take your starting position and you subtract it from your ending position. So you have your ending and you take away your starting, and this will give you displacement. Okay, so where am I talking about? I'm talking about between t equals 0 and t equals 2. So my ending position will be at the position function if I evaluate that at 2, and my starting position will be when my position was starting with time equal to 0. And I'm taking a look at my position functions, and I'm saying that we already know from back up here that our starting position, let's see, what was it? Our starting position was 24 feet. Okay, so at s of 0, I've already evaluated that. That was 24. Now, as far as the equation goes, we haven't worked with it for a couple of problems here. 16t cubed minus 36t squared plus that 24. So I want to evaluate s of 2. What I'm going to do is I'm going to do it like this. Ready? I'm going to say I have 16t cubed minus 36 times t squared plus a 24, but then at the end I'm going to take away a 24 because all of this is s of 2 and all of this is my initial position. So isn't that fun? I'm very grateful right now to say that that is going to disappear along with that. And by the way, when I plug in a 2 here, I get a 2 there, I get a 2 there, and what do I end up with? What I end up with is 2 cubed is 8, 8 times 16 is 128, and 36 times 4 is 144. Sorry, 144. And when I calculate that, what I end up with is negative 16 feet. So that is how much it moved. And you might want to write this sentence down just to be able to envision this displacement again, okay? Remember, 16 feet to the left of the initial position is where we are going to end up. That's what that means. All right. Now, what about this question of what is the total distance? Hold on. What is the total distance then? So if I have a displacement, I know I moved from here to here. That's just looking at the start and the end. What if I did some zigging and zagging in between? So if I move some feet to the left, I moved some more feet to the right, then I moved to the left again, then I moved to the right. I want to take the absolute value of all of those distances because I don't want to talk about negative distances. I mean, definitely I can have negative positions, but when I'm moving, I want to know what the distance was that I traveled. So if I think about this object and I say, okay, at the start, s of 0, I was at 24 feet. Okay, then I know that when I hit 3/2 seconds, right, 1.5 seconds, that I stopped moving. And that's when I changed from moving one direction to the other direction. So where was I at when that happens? Well, we go ahead and use a calculator, right, on the initial function. And that initial function is in my calculator. I don't happen to have it in here already. So my initial function was 16t cubed minus 36, and t is squared, and plus a 24. And I want to evaluate this at 3/2 seconds so that I know what was happening. Where was I when I stopped? You know, if I'm the particle. All right, I'm going to hit Control and Enter because I want a decimal number. Oh yeah, that's just a -3. Okay, so I say that this equals -3. And then I'm going to go in there and say, well, what happened at the end? What position was I at the end? And so I go in here and I'm going to use this function again. I do enjoy this ability. And I say, well, what about when s is 2? When the time is 2 seconds. So here's my s function, and now I'm plugging in the 2. Let's hit Control and Enter and see what we get. And what we end up with is 8. So that's where I was at the end of this time interval. I was at a position of 8. And okay, so now I know at the start I was at 24 feet, and I did a position change here at 3/2 seconds, meaning I was going one direction. Now I'm going to go the other direction. And what I want to do is I want to measure, ready? I want to measure the distance between these 2 points. And one of them happens to be negative. So if I'm at 24 and I go all the way over to -3, then mathematically, you could probably do that in your head. You say, okay, well, I went a distance of 24 and then I'm going a distance of 3, right? And so altogether, that should be 27. Mathematically, the way we write this is that we are subtracting, remember, the end from the beginning. Sorry, the beginning from the end. And so mathematically, the way that works out is that I get the negative of a negative, and that turns into a big fat positive. So that's how I end up with 27 feet. Alternatively, if you want to, you could calculate it like this. You could say you have 27 and you have that -3, and that because these are distances, you want to take the absolute value of both of them, and that's how you end up with a 27. Okay, so either one of these equations is totally fine, and a lot of kids really prefer this one because they don't mentally, they just don't want to deal with negatives. So you say to yourself, I am going to be taking the absolute value of every distance and making sure that I keep track of my movement that way. Now then, what about this next movement? Again, I'm starting at -3 and I am ending at 8, and so there's, you know, this version of the equation. 8 plus, minus a -3 is really 8 plus 3, which is 11 feet, or you could take the absolute value of 8, and you could take the absolute value of -3, and you could add those together and also end up with 11 feet. So all together, how far have I traveled? My total distance is 27 plus 11, ends up being 38 feet. Okay? Now, one other thing that you will be doing on the AP exam is not just handling these kinds of questions, and I got to tell you how much I love this book, because he really gives you a fantastic example of all of the potential questions that you are going to get. This is always an entire free response question. It's going to have some kind of velocity, acceleration, you know, when am I moving left, when am I moving right, what is my displacement, what is my total distance traveled. All of that always appears in a free response question, and but you just never know which of those questions will you get. There is also going to be the evaluating of some kind of graph. Okay, and we're practicing this on Khan Academy, but just to go over it real quick here, it says the graph shows the position function of a radio-controlled model car, and please answer these questions and explain. Was the car going faster at point A, or was it going faster at point B? And when I look at A, I want to talk about how fast it's going. I'm thinking about velocity, and so I'm thinking about the slope. The slope at A is, you know, something like that. The slope at B seems steeper. So I'm going to say the curve is steeper at B. So I must have been traveling faster. Now we want to look at number 13, and it says, when was the car stopped? And if I have a 0 slope, that's when I'm expecting my velocity is 0, meaning that I'm not moving. That is as close to a 0 slope as I can get on this graph. So I'm going to say between C and D, and I'm going to say the velocity is the slope, and it's 0. Well, it's approximately 0 between C and D. So for number 14, we ask ourselves, at which point was the car's velocity the greatest? And by the way, I'm taking a look also at problem number 15, because I've done this before. It says, at which point was the car's speed the greatest? So if I want to talk about the greatest velocity, I'm going to assume that they mean the greatest possible positive number. Okay, and right here at B, that's the biggest positive slope. So I'm going to say the greatest slope is at B, meaning the highest possible positive number. What about E? Well, I see E, and it is definitely steeper than B, and so I would say that that was the greatest velocity, but it's a negative number. So the beautiful thing about asking about actual speed is that I don't care, right, if it was a negative number. If I'm doing speed, I'm always doing the absolute value. So the absolute value of E would give me the biggest number. So I'm going to write that down. The absolute value of the slope at E gives us the biggest number. Okay? Now, what about vertical motion examples with actual balls? Because with E, I was mentioning, what if I rolled this ball down a hill? Right here, what if I rolled this ball down a hill? It would definitely be almost falling, right? Almost just straight up falling. It might hit the hillside a couple of times, but it's not exactly rolling. Whereas if I had a ball over here, I can imagine it rolling pretty nicely down that curve. But if I took a ball and I rolled it down that point E, it's almost like it would be straight up falling. So what if we have vertical motion examples where we actually do need to talk about a ball that is thrown into the air from the top of a high cliff where time is measured in seconds, and we want to find out some cool things about what that ball does. Now, by the way, if I'm on a cliff and this is me and I throw that ball, I'm imagining a negative parabola, right? A sad parabola would be a good equation to use. And that is what he has given us, okay? So it'll have a maximum, it'll have an initial position, and I hope that we could use some pretty familiar tools to be able to find out the answers to the rest of these questions. As far as my initial position, I know that it's 160. Remember that number that's hanging out at the end. But what about number 16 where it says find the initial velocity? Well, what's the initial velocity? The velocity function needs to be found. And again, please do state that this is the derivative of the position function just for your grader. Okay, and so I'm going to write down then that v of t is equal to, what's the derivative of negative 16t squared? Well, it is negative 32t, and what's the derivative of 48t? It is going to be a 48, and what's the derivative of 160? It is 0, and it doesn't hurt to write that 0 down just to remind yourself. Now, if I want to know what my initial position is, then I'm going to plug in that I want to find out what happens when the time is 0. And so I'm going to plug in, ready, a 0. And this is really quite simple. I know how to do this. I get a 0, I get a 0. Well, that's going to be a 0. And so my initial position is, my initial velocity is 48. And it says that we are using feet and seconds. So I'm going to write my feet per second. And that is going to be my initial velocity. By the way, in other books, you might see this be called v sub 0. Not evaluating v at 0. That's what this is, evaluating v at 0. They will call it v sub 0. But they mean the same thing. These are exactly the same thing. So it's kind of amusing that we have these two different notations that different people will use. All right, it says for number 17, at what time does the ball hit the ground? Well, hopefully you remember then that if I'm talking about a sad parabola and if I'm going to hit the ground, I guess I could have drawn the ground a little bit better here. If I hit the ground, aren't I basically talking about, ready, what? The X-Intercepts? So I might get an X-Intercept over here. This is extra. Whatever number I get on that side will probably be extra, but this is the time I'm looking for. So this is for number 17. That's the time that I want to find. So how do I do that? Well, how do I find the x-intercepts of a parabolic equation? Well, I can, ready, just solve it. And I love my calculator, so I totally intend to use it because nobody said I couldn't. So my initial function was negative 16, oops. It was negative 16. Oops, I need to use the actual negative sign. Where's that actual negative sign again? Where are you, negative sign? Oh, there you are. Okay, so negative 16t squared. Oh, didn't I want to solve this? Absolutely. I want to solve, and I want to say negative 16t squared plus 48t plus 160 ends up equaling 0 when does it equal 0? At -2 or at 5. And that means this guy was definitely factorable. You know, if you really wanted to factor it, you totally can. Let's say that we're going to set s of t equal to 0, and I'm just repeating the work that we just did on the calculator just so that you could see. If I factor out a negative 16, I get a t squared minus a 3t minus a 10. That was a quadratic that I can find, right? I can factor this t cubed minus 3t minus 10 into a t minus 5 and a t plus 2, and then I still have that negative 16 out in front. But if I divided by it, it would disappear, right? Because 0 divided by negative 16 is 0, so I can just get rid of that constant in front. That's so handy. And I find out then that at t equals 5 is a good moment to say that it is hitting the ground. At t equals negative 2 is another moment where it's hitting the ground. But remember, that was my extra answer, and so I'm just going to say that at 5 seconds, right? Because this answer, when time was negative, remember that, when time was negative, I didn't care about it, okay? So for number 18, it says, at what time does the ball reach its maximum height? Ooh, I love that question. Remember, we're going to talk about maximums here because we have a sad parabola, and isn't that the same thing as just finding the vertex? Indeed it is. And so if you want to just find the vertex of this parabola, you are allowed to. However, I am thinking to myself, you know, this is pretty easy. I know how to find the derivative, right? And in fact, did I do that already? I did. And so this is the beginnings of that first candidate tests that I mentioned we're going to start working with probably in the next chapter, where I'm given a function. If I want to find where a maximum is, I need to find that the slope of the derivative is equal to 0. So the slope is 0 means I'm going to find, ready, when v of t's derivative, when v of t, which is the derivative of my function, my position function, when v of t is equal to 0. That meaning that the slope is 0. So I will say that v of t was negative 32t plus 48. I kind of want to do that in orange though. Negative 32t plus 48 is equal to 0. I'm going to add 32t to both sides. I'm going to have 32t equals 48. And then I'm going to divide by 32. And by the way, t equals 3/2, which is 1.5 seconds. And that is the time at which the ball reaches its maximum height. It's the top of that parabola, which can be found by setting that slope equal to 0. Now, this is the first time you're seeing this, but I guarantee you we're about to do it about 1 million more times. So you will get more familiar with that step.